Now we want to create our API token in the Akamai Linode console. To do this, go to your username and click on API tokens here, create a new personal access token, and I'm going to call this try IaC Terraform, and I'll go ahead and have it expire in 1 month. These tokens are so easy to create that you might as well have the expiry window very short. Now, generally speaking, I would say you should add only the things that you need for this token. You probably don't need everything, so I'm going to go ahead and just do select all for none. And then I'll go ahead and say I want the events. Terraform probably needs the events. I'll do firewalls, IPs, linodes, node balancers, object storage, and volumes. Okay. You can obviously pick and choose these, and since it's so easy to create these tokens, you can always verify the permissions later. So inside of terraform.tfvars, I'm going to go ahead and bring in my token in here, and we'll save it. And so now back in main.tf, I can actually use that token. So the way it's done is we have two options here. First off, what we could do, the simplest one, is just do var.linode API token, right? So having that extension will help us with this automatic syntax filling out. And so that actual var.linode API token, of course, is coming from the variable itself, and we also have reference to how to use it. The other way to do this is something called string substitution. So you can use double quotes, $, and then curly brackets. Make sure that you open and close it, or curly braces. And then you can actually pass in var.linode API token in there. Using string substitution will just enforce that it is a string or treat it as a string in most cases. So I'll go ahead and just leave it in as this because this is the most simple and it's not necessarily something we need to spend a lot of time on, but it is nice to know. And of course, the next thing that we could do is just verify that variable, or we could also use the string substitution and see what happens. Like, does this actually output that value? Because when I just did var.linode API token, it doesn't say it, but if I do it in a string substitution, it still does that sensitive value, which is great. So we'll look at string substitution more. We'll use it again. But the general idea here now is I have the API token necessary to actually start provisioning resources using the Linode provider and, of course, the Akamai Linode API and the Akamai Linode service. Now we're going to go ahead and provision a Linode virtual machine instance using Terraform. So jumping into the registry itself, we jump into documentation and we just look for Linode instance. Quick search there. We've got resources here. There are data sources as well. That's something we'll talk about later. But for now, Linode instance here, and here's the sample usage that we've got. Now this sample itself was, left out on the provider. I'm going to go ahead and leave this in as the provider sample as well. And then in main.tf, I will also bring it in right here. Okay. So authorized keys, this is not great just yet because I don't actually have any authorized keys that I can use. We will look at that, but for now, I'm going to leave that out. The root password, though, this right away should hopefully set off your alarm bells as to like, oh, I probably don't want this for my root password because it's not a whole lot different than my Linode API token. So instead, what we're going to do is jump into our variables. I'll copy the Linode API token, and I'll call this my Linode instance PW. Default, I'm going to not have a PW or a default for that specific variable. So back into main.tf, we're going to change this to var.thatpassword. So with that password in mind, one of the other things that you should be thinking about is like, okay, I just created a variable that's sensitive. What do I need to do? I need to add it into terraform.tfvars, and I actually need to create a password here. Now, one of the ways I create a password is by using OpenSSL. So that's typically available by default. So OpenSSL and then rand-base64, and then we can use 32. This will be a good enough password for us that we can use now, and I'll save that. We will absolutely come back to the authorized keys for the SSH keys and this particular workstation, but we'll do that in a little bit. The actual type and region is something else that we want to take a look at. So going back into the documentation, if we scroll down a bit into the arguments, we can see all of the regions and types here, right? So it's quite literally listed out. In my case, I have a JSON parser on here, which makes it a little bit easier to read. So feel free to do that. I'm going to use the G6 Nanode 1 instead of central or standard 1. The region, in this case, doesn't really matter. I also want to use a different version of Ubuntu. So back into my console for Linode, I will go ahead and create a new one and just take a look at the available items here. So we did 22.04 for a workstation, so I want to do the same thing here. And that again has another API that you can look at that gives you all sorts of access to the various instances that are available to you, the image versions that are available. So now that we've got that, we've got our region and type, the main things that need to be in there. We have a password. All of this other stuff I just don't need right now, so I'll go ahead and leave those out. The label itself, too, we are going to go ahead and leave out as well, so we can see what that looks like. You can absolutely label this however you'd like. This label itself is directly for the instance. So everything, all of the arguments that are in here go directly to the resource itself. This argument, this sub-label or subtitle, that one itself, in this case, is web. But much like I said when we did the sample, this is a sub-label itself that you can change for Terraform. You can change it at any time. It doesn't have to be web, which we'll look at as well. But for now, I've got this resource and all of that. I'm ready to do the next step, which will be Terraform and plan. If I do Terraform and plan, it gives me exactly what's going to happen. It shows me examples of what will happen with it as well. It shows me what it knows and the things that it doesn't know yet, and where it's located, resize disk, all of those sorts of things. So I'll go ahead and now run, as it says, Terraform and apply. So the plan is something we could save. We could save this plan and then apply it later, which is something you might do when you want to not automate this process. But I'm going to just leave that for another time. But notice that when I run apply, it's going to tell me that I didn't provide a plan. Or, well, I guess it's not telling me that right now. But that you didn't use the out option to save this plan, so we can't guarantee these actions will happen if we run apply. But once we do run apply, it's going to prompt me for yes. So I'm actually going to say no to start out, and I'll look at another thing of apply, and that is -auto approve. If I hit enter here, this will show me that it's creating that same instance. So it's a lot like saying yes to that plan, and it's just going to automatically execute. So running the auto approve is something you're going to want to do on a regular basis while you're learning, but not on a regular basis when you go into production. Instead, what you'll do is you'll have that plan, you'll output it, and then you'll apply it, which we'll look at in the next part. But for now, it's going to go ahead and run through this creation process, and it's going to take only a matter of maybe a minute, maybe a couple minutes. It really depends on how long the console takes to just boot this thing up. Sometimes it's in seconds, sometimes it's a minute, right? So this took less than a minute, but as we see here, the label was given to us. So we can do something that I think is really cool, and what's really important about Terraform is I can just change the label. We'll leave it in as simple instance, and once again, I'll do this plan, and I'll see what happens here. So the thing that's happening is it's going to change the label. That's it. It's only changing something. It's not adding anything. It's not destroying anything. So I'll go ahead and now apply this. And again, auto approve just to speed things up, and I don't have to type too much. And so there we go. It's now changing that. And if we look in the console itself, I might have to refresh, maybe not. It says the name that came through. This is great. But what if I wanted to have a more drastic change, right? So let's say, for instance, I wanted to change this to 20.04. This, in this case, if I go to plan it, it's now going to say 1 to add and 1 to destroy. It's going to quite literally delete the old instance itself, right? And then create a brand new one. As it says, it forces replacement on that plan because of what this attribute can do. I'm going to leave it just as 22.04, and we will see this force change in the future. But for now, just keep in mind that it's that simple to provision an instance and also that simple to just change it. So, of course, if you're familiar with version control, and even if you're not, we can see that this can track over time, and we can see exactly the outputs of what's happening over time as well. And it's going to be a lot easier to recover. So let's go ahead and now take a look at outputting that plan and then using that plan as we see fit. So when it comes to making changes in Terraform, how is it happening exactly? Well, first off, let's make a change. So inside of the image, we're going to change it from 22.04 to 20.04, and we'll run Terraform plan. And of course, we can see what's happening. It's going to want to make a bunch of different changes, but how does it know that it should make those changes? Well, this actually all comes down to terraform.tf state. So this file itself is a file. It's in a JSON format, but this file itself provides all of the details about the current state of the infrastructure. So it's not querying the API for all of the resources you provisioned. Instead, it's storing the provisioned resources based off of the last time you made changes, right? So if we actually scroll down here, you can see everything that's going on with the current state of things. So what the plan is doing is it's taking the new state that you changed in your file and it's comparing against that TF state. Now in this case, my terraform.tf state file is stored locally. This is okay in the sense that it allows me to do this really quickly, but it's locally on the remote workstation. So if I accidentally deleted that remote workstation, that state would be gone completely. So it's definitely something we're going to want to change in the near future, but it also gives us the ability to output this plan, to store this plan that we are wanting to change. So I can use plan-out and I can set it equal to my plan, hit enter, and this will actually store a new file in here called my plan. Now, the important thing about this state, TF state, and my plan is they have sensitive information or could have sensitive information in there that you never want to expose. So the vast majority of the time, I would recommend to new users of Terraform to not use this plan, but rather to have a remote state like we'll do later. But for now, with this plan, you can also apply it with Terraform, and then we do something like input equaling to false and -auto approve being true, or just -auto approve. And then you can actually do apply, and we're going to grab my plan. I think I have those in the incorrect order. So let's try that again with Terraform apply -input being false and -auto approve, and then my plan, and hit enter. This time it will just go ahead and apply those changes for that plan, right? And it's going to take a moment because it's got to destroy everything and bring it back up. But what it's not showing me is what we saw before when we did apply, is it would actually even output the plan of the things that are changing. And of course that also updates my Terraform state once it's all finished. At this point, I don't have any resources because it deleted one and now it's in the process of creating a brand new one. So it will take a little bit of time, but it does have different versions. So it does have instances that do change over time as well, based off of how often you change the state. But once again, those versions are something we don't need to track. We don't need to track those versions. We can just track the versions of the files that are making the versions of the state itself. So, but of course, now we see that our plan is still out there. It's still exposed. But once it actually finishes, I'll go ahead and delete that plan because we don't need it anymore. And it's not something I'm going to continuously use. So instead, we just really want to focus on that TF state itself versus trying to output plans, storing plans, and all that. But there we go. It now changed. And if we look in TF state again, everything's back. All of the information about our current state is back in there. So I'm going to go ahead and once again delete that plan, and we'll go ahead and change this back to 22.04. And now I'll just go ahead and do the apply. So Terraform and apply. We hit enter. I'll again say yes, and then it'll make those changes as we need to. So I'll let that finish. Now we're going to go ahead and create an output string, an output value that will come up in the console itself. Now this output value is going to be so I can SSH into this instance, for example. Now, much like variables, I can actually say output, and then let's do VM SSH string. And this will be based off of what's happening in this resource. Now, I'm going to fill it out here, but then it will be in its own Terraform module in just a little bit. So the first thing that I want to do is I want to pass in a value here. Now the value I'm trying to get is the SSH value for the root user, and it's going to be at this instance. We'll take a look at how to get this value in a moment. And so I just want to be able to fill this out. And this is not going to be sensitive data, so I can just say sensitive being false, just to be verbose about it. Now, at some point, maybe it will be sensitive data based off of the IP address, but in our case, we're not going to have it as sensitive data. So we just want that output string. So let's take a look at what that might be first by going into the registry. So back into the registry itself, we've got our instance here. If you look at attributes reference, you can see all of the various attributes that are available to you for your instance. So let's go ahead and jump into the Terraform console. Okay, so I've got an invalid expression here, so I'll go ahead and get rid of that one there, and we'll jump back into the console. And so to actually grab anything related to a resource, we can use the resource directly, and then something like web dot, well, let's do status. And I see that it says running. So that's this status right here. Next would be .IP address. And lo and behold, that is the value I actually want inside of my output. So let's go ahead and try that one. I'll go ahead and copy this, and we will now bring this in here just like that. And I'll exit this, and we'll do Terraform plan, and we'll see what happens with this plan. Changes to output. There it is right there. So it's now giving me my SSH key that I might want, and I can just go ahead and apply this and do auto approve. The thing about this is it's not actually making any changes, but rather giving me this output so I can now run that SSH command right in line just like that. Super simple. Of course, the password itself we have stored inside of this instance password, and we can get in just like that. So what's happening here is, of course, my local machine has an SSH connection to my workstation. My workstation has an SSH connection to this now new instance. And so if I exited out of here and I took a look at that SSH, and on my local machine, opening up the terminal itself and doing that SSH here. So what I'm going to do is I'm going to grab that password again, and we'll go in, and there it is. So it's literally the exact same instance. But now I'm going from my local machine instead of my workstation, which could cause some latency things overall. But that's not really the point. The point here is that I can now output these values here for a real instance that I might want to use. So before I go any further on, this instance itself, I want to actually change how many instances I create right off the bat with this exact same configuration. So let's go ahead and just change this count to 2. So it's now going to create 2 of these instances, but this actually creates a problem with our label. On Akamai Linode, you can only have one label of the same kind. So if you use the same label over and over, there's going to be an API error. So we're going to just comment that out. We'll let the Linode API actually create the labels for us, but we'll leave that count in. So now again, we'll do Terraform and plan. This once again should have everything that we need for this, but I have one issue, and I've got this missing resource instance key. This issue is because I've now turned the Linode instance.web into a list of items. So I'm going to go ahead and leave this output out for a moment, and we'll bring it back as well. So once again, I'll do plan, and then we'll go ahead and apply this plan, and I'll go ahead and do auto approve, hit enter. Okay, so in that plan, we see that it has 1 to add, 0 to change, 0 to destroy. So the original one is still there, but it's going to go ahead and add another one, which we can see inside of our console itself, right? So it's going to show us that other one that's coming up. And that next one has a label that's just not simple instance. So it didn't change the old label at all because I never told it to. I just got rid of the actual argument for it. Right? So it's not going to just like change something arbitrarily unless you declare something different. So what I want to do though is maybe I want to actually have this count being a variable. So once again, we can come in here and I'll do my variable, and this will be now my Linode web instance count. Right? And so the default here is going to be 2. And this time I might actually want to put in the type of number. Actually declare the type, because it makes a lot of sense right here to have the actual declared type. It might make sense with these other ones, but those are sensitive values. And so this one is just a default value, if you will. I actually don't need to change this variable at all. And of course, you can add in a description saying the number of instances for web to create, for web servers, or maybe web app servers to create. Something like that, right? And so we have this default here. So that means that I don't actually have to put anything in terraform.tfvars. I can just leave the default in there. And so back into main.tf, we can now use var.linode web instance count. And of course, at this point, we should have everything changed and all that. So if I do terraform plan, nothing changed, right? As soon as I take that variable and I put it into tfvars, and let's say, for instance, I put it to 0. Now, if I do the plan, it's going to tell me, oh, it's trying to delete 2 of them because I had 2 of them. If I change it to 100, we'll go ahead and do the plan. It's going to try and create, well, 98 of them the exact same way. But let's keep these numbers a little bit more manageable, and I'll put it in at 3. Okay, so once again, we do that plan. The plan shows me that I want to add one, and I'll just go ahead and press up at auto approve, and it's going to go ahead and start creating that. So this also presents a new challenge for us, and that was the label itself, as well as the output that's happening here. And so we need to actually take a look at what's happening within the instance itself. So the first thing that I can do is I can jump into the console once this finishes creating. So I'll come back in just a second. Okay, so with that provision, let's go ahead and jump into the console. And now let's take a look at this resource. Once again, we do the resource, web, hit enter, and now we see this bracket here. So what's happening is if we scroll up, we actually get that resource, but we also get 2 others. So we've got these brackets, which show that it is an array. So if we actually use 0, as in the first item in there, we now have that single one, and I can do .ip address. I can also do the second one and get .ip address, and I can do the third one and .ip address. So, of course, the indexing starts at 0 and then it goes up from there, but those are the 3 that we have, those 3 values there. So what we can do on our output string is to keep things simple. For now, we will go ahead and just use 0. Yes, there's a way to iterate over this data, which we'll look at, but for now, we'll just leave it as 0. Now, the other thing is the label itself. Perhaps we don't want this label like this. Instead, we want the try IaC, TF dash. And in here, what I can do is I can use count.index. Now, the reason I can use count.index is because of the instance itself. So once again, I'll exit out of the console. I'll do terraform plan. What should happen is it's just changing the labels to everything, and it's going to be the label based off of the index value for that particular item. And so we can have thousands of them in there. And this also might make sense to now then bring in tags again and start to tag things like try IaC, not with single quotes, but rather with double quotes. So try IaC and maybe web. Right, so it's like a group of things are now putting together, and it's based off of what's happening in the console. Because again, remember, all of these things are about what's happening in the console itself. So we save that, and now I'll go ahead and apply those changes and auto approve, hit enter, and of course that's going to create all of those things or make the changes as necessary, and it will also tag these things as necessary as well. And it does it really, really quickly because it didn't do major changes. It just did label stuff and tags, that's it. But now we have a much better look at how to create a lot of these instances. Now, of course, that's not the only way. What you could do is you could just create another one like this and say web2 and just call this simply web2, right? So that's basically the same thing, but we don't have to repeat it over and over. We could just use that count value. So the other nice thing about this count value is you can actually change the value to being 0, which means that, of course, everything else goes away. The actual instances all go away if it's at 0, but the configuration can stay. So that part is also really nice of that count. I'm going to leave the count in as 3. You can experiment with 0 as you see fit. But the nice thing about that, of course, is if you have somebody on your team that just needs to use something for today or this week, you can have it in at 1, give them some basic things, and then bring it back to being 0. Okay, so now what we want to do is take a look at how to actually add in some of those authorized keys, some of those SSH keys by default. There's a couple different ways on how we can do this. The first way I'm going to do it is pretty straightforward. I think you might have an idea of what this might look like, but the idea being these authorized keys, and what I'll use is var.ssh public key. And of course, it has to be the public key itself, and of course, the reason I'm getting this red line here is because I never declared this value, and I have that extension activated. So let's go ahead and declare the value now. In my variables file, I'll go ahead and do variable, and we will declare our SSH public key. And of course, you can add in a description, something like our SSH public key value. Okay, so this is not actually a sensitive key. This key itself can be exposed. It's made to be public. It's made to be shareable. That doesn't mean you always want to do it necessarily, but it can be. And so I'm going to declare this as a type of string as well. And of course, just like we've seen with other variables, I can just come in here and add it in here, the actual value in here. And so to get that value, one of the things I could do is I could use cat ~/.ssh/id_rsa.pub. Now, of course, this assumes that you already have an SSH key, which I do not. So you should know how to generate SSH keys. It's the same on basically every machine. It's SSH-keygen. You hit enter. You can save it in the root file, which is what I'm doing right now. We're going to go ahead and enter the passphrase twice, and there we go. And so now I go ahead and see this is my password here. The passphrase I used was nothing. I didn't actually set one, mostly so it's easier with Terraform. So I can grab this here and paste it in. And there is my SSH key. Great. Probably not that surprising in terms of how this would end up working. So let's go ahead and now clear everything out, and we'll do Terraform and plan. And we get this type of string. I made a mistake there, so let's go back into that variable. This should just be literally string, no quotes around it. And so I try that again, and now it's going to plan this out. And so what it's actually going to do is have to destroy all 3 instances because it needs to install that key, right? And so what's going to also happen is it's going to update the state with that same exact key. So let's go ahead and apply it now. And we'll go ahead and do auto approve and hit enter. So while that's working, there is yet another way we can consider using the SSH keys. And that is by having a default value. So I'm going to go ahead and copy this variable here. And this is going to be now SSH key, public key path. So the actual key path to the value. So local key path to the SSH public key value. And the default is going to be based off of ~/.ssh/id_rsa.pub. Okay. And so once again, the path itself, we're basically saying, hey, this is the path to the key. It doesn't actually have the key at all. And basically, it's going to augment what we just did here. So we could have both things, or we could use one or the other. The challenge is with this public key path is we actually need to open this key, and we need to look at what's inside of this value. So to do that, I'm going to go ahead and open up the Terraform console. I'll just open up a new terminal window here. Let's see if I can jump into the console while it's loading. Looks like I can. And so I can grab open var.that path. And so before we look at the contents of this file, let's take a look at a built-in function to Terraform called file. It quite literally reads the contents of a file, assuming that you pass them a valid path. And that's essentially what we're going to do now. So we'll do file and var.ssh public key path. We hit enter, and there is that value. Now, there's a couple things that are interesting about this EOT here. Now, if you're familiar with that, that's just opening the file and closing the file. But basically, let's go ahead and change this into being a string substitution item here. So I'll just pass in this whole value as part of the string substitution. That EOT is still there. Okay. So what I can then do is I can actually split up this file. So we'll go ahead and do split, and I'm going to get rid of a new line there. So at the very end, we see that there's an empty line here. This is going to be a new line. And so I want to split it up, still use that file contents, and take a look at that. Now I've got two list items here. So I've got an empty list here, but then the actual value of that SSH key. So I can use the 0 index and get the actual string out just like that. Great. So this value here can now be used in place of the var.ssh public key, right? So basically what I would then do is I would come in here and just paste that. So I'm splitting it up and making that work. Now the reason I use the 0th instance or the index value is because of that new line that comes in. So I actually need that proper value, which is exactly why it looks like that. Great. So with this in mind, I can once again do the same thing. So if I exit out, let's go ahead and see, make sure that everything was done correctly. It was. And I'll do Terraform and plan. Now, when I actually changed the key, it wanted to do changes. I haven't changed the key. It's still the same exact value. It's just using a different method to extract that value. And that's all. Great. So I'm going to go ahead and get rid of this public key here. I no longer need that variable. Instead, I'll use this path. Now, the thing I like about this path is that then if I were to put this on like GitHub and have GitHub Actions do everything for Terraform, I could then still specify this path, but relative to GitHub Actions and no longer being this SSH ID RSA path. In other words, this tfvars here would just have that path, right? So we would come in and we would declare the default for that path. We would come in just the same, and we would change this as we need it. So ~/ssh ID RSA.pub. And of course, make sure it's .pub, not the private key. I think there will probably be errors if you try to provision it with the private key. But that's how we actually can use those SSH keys. And of course, it's a list, so we can have many of them in there. So if you needed additional ones, you can. And there are ways to write conditions to make this a little bit more flexible to having a bunch of different keys. But I'm not going to worry about that flexibility. The only thing I want to test now is I want to actually test out the SSH process. So auto approve. I shouldn't have to actually enter the password in any longer. So if I do root, I say yes, and I'm able to actually enter into that virtual machine without doing the password, which is exactly why we have these authorized keys here in the first place. So now that we've got this, let's go ahead and take a look at how we might additionally add things to this particular instance. We are now going to update our Terraform project to use a remote backend. So every time we change something in Terraform, it goes into this local terraform.tf state by default, which is fine while we're learning. But what would be better is that I can move all of the code, but then still have access to terraform.tf state. So in other words, if I needed to move this to another machine, I would still be able to use it. If I were to use something like GitHub Actions or other CI/CD tools, I'd still be able to use it, as long as I actually recreate this terraform.tfvars and the backend like we'll do right now. Okay, so it starts off with we go into our main.tf where the Terraform module is being configured. So we do backend of simply S3. Okay, so we can add in arguments in here, or I can use a third party or a file, an external file, to actually declare all of the arguments for this S3 bucket. So the idea being is we have to have an object storage bucket. That bucket will store our TF state file. So to do this, we're going to go ahead and take a look at the configuration for various backends. And in this case, it's the S3 backend. So if you do a quick search on Terraform for S3 backends, you should come here. And there's this configuration set that we're going to go through. And we're going to be using -backend-config. And so that's what we're going to do. Okay, in here, let's create a file called backend. Now, it's not always called backend. A lot of times it's going to be called something more like config.object_storage.tf backend. That's a lot more verbose, but I'm going to just go ahead and stick to just simply backend, but I will still put in this into getignore, and then I'll go ahead and also put in backend to getignore as well, because we don't want either one of those things accidentally checked in somewhere. Okay, so we'll delete the object storage one and just go off of simply backend. So the first configurations we need are specifically to Akamai Linode object storage, and that is going to be skipping a bunch of things. So if you're familiar with S3 storage and who pioneered it, it was done by AWS as far as I know, but now a lot of services have S3 compatible backends. So what we need to do is we need to find all of the configuration for skipping the AWS configuration for it. And so we're going to go ahead and copy all of these. Now, the reason I'm mentioning this now is because these skip portions have been changed over time. So I'll just go ahead and say skip equals to true all across the board on each one of these items. And it used to just be 2 things. Now it's 5, and who knows, maybe it's going to grow beyond that. So this skip could also be written right inside of this backend configuration here. But the thing I like about doing it within the backend documentation is if a new skip comes out, I can just update all of my backend files that have this really, really quickly by just adding that new parameter, which is why I do it this way. Okay, great. So now that we've got that, what I want to do is I want to actually add in the various object storage related things. First off is going to be our bucket. Then our key, which I'm just going to call terraform.tfstate for now. We'll see if that ends up changing or anything like that. Next, we'll go ahead and put in our endpoints. This actually has changed over time to now having more of a mapping or basically a dictionary here. And we'll have to put in our actual endpoints. And then we'll also have to do our access key and then our secret key. So since there's the access key and secret key, that's another reason to never have this backend come in. And perhaps you don't want your bucket to be exposed either, in the off chance that your access keys and secret keys are gone. So we need to go one by one here. First off, we need to create a bucket. So let's go jump into object storage on Linode. And we'll go ahead and create a new bucket here. This one, I'm just going to give it TF IaC state. I'm not going to put any dashes in there or anything like that. And then I'll go ahead and choose my region of Seattle. Okay, so let's go ahead and create this. I will also enable object storage for this, which is a minimum of $5 a month charge. There is my bucket. The next thing I need to add in, of course, is going to be my region for that bucket, which will be USC1 for Seattle. So USC1. Great. So I've got those few things configured. Next, I need to grab the endpoint itself. And so you might think that this is the endpoint, but you actually do not need to include the bucket there, but just everything else. Straight up simple. We'll go into our access keys now. We're going to create our access keys. Once again, try IaC. And this time I'll just go ahead and give this the access key label, something like that. And we'll go ahead and limit the access specifically to that one bucket. Granted, I don't have any other buckets, but if you did have other buckets, just limit it to this single bucket itself, because we don't accidentally want other things going in this bucket. I literally just want it for my infrastructure as code state, more specifically for Terraform. Now, we could put other things in here because this is just going to add one file, but I like to keep it really, really concise. Every once in a while, I might have a Terraform bucket that has multiple Terraform projects in it, and in which case I would do something like project name /terraform.tfstate. But the thing is, the actual naming process for all this is a little bit finicky at times, so I'm just going to keep it as straightforward as I possibly can. So next, we're going to go ahead and do our access key, and then our secret key. And of course, we don't want to share these at all, so make sure you don't. Okay, so now that I've got this, what I want to do is I actually want to do terraform and destroy. I want to take everything down, right? And so I have backend things modified here. That's what this warning is. So let's go ahead and comment it out for a moment. I'll destroy everything because my local state will no longer be local, at least local to my remote workstation, but rather it's going to be stored in the backend of S3, which is why we want to take it down first. Right? So taking it down is very similar to just wiping the slate clean in terms of our entire project. So typically speaking, I would actually do this configuration first. This would be the first step into Terraform. I would do the backend before anything else, including any of the other API providers or services. That's just so my state is cloud-based, so I can use it anywhere. And also it's a little bit more resilient, right? So with it down, I'm going to go ahead and delete everything from Terraform. So we're going to go ahead and delete .terraform. We're going to delete the terraform.tf state. We're going to delete that backup as well. And now all I'm left with really is the code that I created. And so this code itself can easily be versioned, right? We would just have to replace the terraform.tfvars as well as this backend file to get everything right back where it needs to be. So with this in mind, this is now kind of like as if we were starting fresh. If you remember, we did Terraform init. That is how you initialize your project. But now with this backend in here, if I do init, it's going to prompt me for all of the S3 bucket stuff. So if I could hit Control C or Command C, I can actually close that out. And now I can actually pass in the backend-config of that backend file. That, of course, is this, and it's relative to here. I'm going to go ahead and hit Enter and run this installation. Great. So it looks like it worked correctly. Now, the reason that I mentioned that I do the backend first is also to, well, diagnose any issues that might come up when you do this. Right, so I actually tested this off of this video with bucket like that, and then terraform-IaC, something like that for the key file. And for whatever reason, that just wasn't working. It might be a glitch with the current backend situation, but overall, this is what worked for me. And of course, if you're having any issues here with like an API access problem, just play around with your bucket, maybe even change the region. These are the 3 values you'll really need to change. And of course, if you do change the region, make sure you update your endpoint as well as your access keys if you ever change the bucket whatsoever. But now we have our actual state file will be inside of the object storage. So let's go ahead and do Terraform and apply, and we'll do auto approve. And of course, this is going to take a moment to actually provision all 3 instances. But what's going to end up happening is inside of my bucket here, I will be able to see that state file. It will now exist inside of this bucket, which is going to be super nice once that's all said and done, which might take a minute or so. All right, so it just finished after about a minute. And so I'm going to go ahead and refresh in my object storage. And there is my terraform.tf state file. It's not very big, but it is now stored in object storage. So in order for me to use this elsewhere, like if I was using GitHub Actions, for example, to automate all of this, I would initialize that backend, and then I would also have terraform.tfvars with the correct values in there. And then I would just run the Terraform apply, auto approve after I ran the init file, because you want to initialize it with that backend, and then you're going to go ahead and apply it. Once you run apply, it's going to compare your files with what's on the S3 bucket. And so now it is a cloud-based instance of Terraform. And before we go, I just want to mention that I will have this example of configuration so you can replace the values for your particular project. Now, I also will say the access key and the secret key can all be environment variables. Just check the documentation for that on how you might go about doing that. But you still might want to have this backend file every once in a while. And then once again, it's going to be Terraform and init, and then backend-config, and then, your backend file, something along those lines. So yeah, it's pretty nice that we can do this now, and we can add it wherever we need, as long as we have the correct credentials, the backend file, and terraform.tfvars, then we'll be good to go and be able to rerun all of this code as we see fit, whether it's GitHub Actions, whether it's another virtual machine, whether it's on a local host. We can use all of those places to help manage this project at the same time now that it is cloud-based in this way. It's pretty cool.